Hello there, Gregory Carlson here for College Algebra, section 2.8, part 2. We just found f plus g, f minus g, f times g, and f divided by g. Let's find their domains. And to find their domains, it would help to start with these two input functions. So we know that a domain is the collection of the inputs, and sometimes there's restrictions. For example, we can't have a negative inside our square root, and we can't have a 0 in the denominator of a fraction. So the domain of just f by itself, okay, so the domain of just f, let's look at it. We need the inside of here to equal 0 or be positive. So we solve the equation 3x minus 2 is greater than or equal to 0 to find the domain of f. So let's solve that. Plus 2 plus 2. 3x is bigger than or equal to 2. Divide by 3, divide by 3. X is bigger than or equal to 2/3. So there's the domain for f. And the domain for g is the domain for g, DOM period g, is going to be basically x can't be 0 because we can't have a 0 in the denominator. That would be undefined. So it helps to know the domain of f and the domain of g. So in f plus g, we see we have both functions just being added together, which means that both of these restrictions happen. But look at this. Do you see how x is bigger than or equal to 2/3? That means that we automatically don't have 0 because 0 is smaller than 2/3. So since we have x is bigger than or equal to 2/3, it would just be redundant to say that x can't be 0 because it already can't be 0. So the domain of this is everything bigger than and including 2/3. So bracket 2/3 parenthesis infinity. That's the domain of this one. We don't need to put x can't be 0 because that's 0's over here. And so we don't need to put it. In fact, the domain of this next one is going to be the same. This subtraction doesn't really affect our domain much. We still can't be 0, and we still have to be bigger than 2/3. So that domain is going to be the same. We can equal 2/3 because it's okay to have a 0 in a square root, but we can't be smaller than it. How about multiplying them? Does multiplying them make a difference? Nope. We still have x in the denominator. Like if you wanted to, if you didn't want to put 1 over x here, you could have divided this whole thing by x. So we still have x can't be 0, and we still have x has to be bigger than 2/3. So again, domain's the same thing. These domains won't always be the same, but a lot of the time they are. Now this one's a little tricky. In this one, our x became on the numerator. So in this case, x could be 0. So this restriction no longer takes effect of x no longer being, x can be 0 in this one. However, because of the square root, x still can't be 0. We still have to be 2/3 or bigger because of this restriction. So the domain here is going to be the same as the other three parts, 2/3 to infinity. If this had been worded differently, like maybe if it was 3x plus 2, then 0 would have been included. But based on how it is, we need to be bigger than 2/3, so it's 2/3 to infinity. So just notice that this fourth one was a little different. X could be 0 here, whereas it couldn't be 0 in these previous pieces. Let's move to page 31. Do a little bit more with functions, operations, and composites. On this next page, you see I have f right here and g right here. And it says, what is f plus g of 2? So in other words, all we have to do is look at 2 on the graph, which is right here, x equals 2, see what the point is for f, and see what the point is for g. So right here for 2, it looks like this first f part is going to be 4. It looks like at 2, the g part is -2. So that's the point f of 2 and g of 2. It's telling us to add these together, so we'll do that. 4 plus -2 is equal to 2. So the answer to part A is 2. How about f minus g of 1? Well, f of 1, because here's f, f of 1 equals 1. G of 1 now is negative 3. Do you see that? At 1, the g value is negative 3. And what does it want us to do? It wants us to do f minus g of 1, or 1 minus negative 3. So in fact, those two negatives become pluses. So that's going to be 1 plus 3, which is 4. So the answer to part B is 4. Notice, you just find f, find g, and then do whatever it's asking you to do right there. What is f of g of 0? So don't just do 0 times this. That's not what this means. This means find f of 0, find g of 0, and then multiply those two numbers together. So it's not necessarily 0. However, look at this. F of 0 is 0, so it doesn't really matter what f of g is. If I go to g of 0, that's negative 4. So they're asking us to multiply 0 times negative 4, which in this case will be 0. But just recognize that it's not always going to be 0. Let's say this had been bumped up a few spaces. It would have been that number times this number, because we're only evaluating it at 0. We're not always multiplying. Okay, let's get on with it. F divided by g of 1. F of 1, actually we can repeat this right here. F of 1 was 1. We're dividing it by g of 1, which was negative 3. So the answer to that part is just negative a third. So that's how to find f plus g, f minus g, f times g, and f divided by g using graphs of two functions. Just find the 2 points on the two functions and either add, subtract, multiply, or divide. Notice that it would be different if we had done g minus f instead of f minus g. That would have been negative 3 minus 1, which would have been a different number. All right, let's do this next part. We've got a table over here, so instead of a graph, this time they've given us a table, and hopefully you can read it. I know it's a little small. Here's our x values. Here's the values for f at those values, and the values for g at those values. So this will be pretty easy. Let's find, sorry, it's not really focused, but hopefully you can read it on your paper. Let's find f plus g of 1. So here are the values for 1. So we're going to add them. The value for, let's do part A. F plus g of 1 is just going to be f of 1 plus g of 1, or 11 plus negative 4, which is 7. Pretty easy. The answer to part A is 7. How about part B? F minus g of 2. Well, this time we're going to look at 2. And pay close attention, f minus g. So f of 2 minus g of 2, 11 minus 6 is 5. If that had been a negative number here, you would have been subtracting a negative, which would have turned it positive. How about f times g of negative 1? Remember, we're not doing negative 1 times fg. Instead, we look at negative 1, and we see that it's going to be 0 times 6, which is 0. Oops, I'm sorry, I'm kind of off the page. And part D, let's find f divided by g of 0. So here we are, looking at x being 0 this time. So it's going to be f divided by g, which is going to be 4 divided by 0. And look what just happened. We are dividing by 0. So that means that at that point, f divided by g is undefined. You cannot divide by a 0, so we say that it's undefined. So, there you go. Let's, I'm at 9 minutes, so I think I'll go ahead and stop here. Hopefully this makes sense. Notice that g divided by, so f divided by g was undefined, but if you did g divided by f, it would have flipped this, and you would have had 0 on the top, which would have just been 0. So be very careful about the order of these as you're doing them, especially subtraction and division. I will see you in part 3, where hopefully we will be able to wrap this up. See you there.